The copper-silver nitrate lab, period 4, group 1. A single replacement reaction between copper and silver nitrate was conducted in order to determine a quantitative relation between the reactants and products. In this investigation, copper wire was reacted with aqueous silver nitrate for 24 hours to produce solid silver and copper nitrate. The percent of error of silver yielded was 23.99% and might be due to residue being left on the beakers.
In this investigation were stoichiometry, types of reaction, oxidation, and reduction. The vocabulary used in this investigation is spectator ions, oxidation, and reduction. Spectator ions are ions that exist as reactant and a product in a chemical equation. Oxidation is the loss of electrons, while reduction is the gain of electrons. The problem investigated was to determine the molar ratio of copper nitrate. The hypothesis was if copper metal is reacted with silver nitrate to produce silver metal and copper nitrate, then the copper produced in the copper nitrate would be a copper ion.
The materials you need in this lab is a 6-inch copper wire. The materials needed in this lab is a 6-inch copper wire, 15 milliliters of silver nitrate, one 50 milliliter beaker, one 600 milliliter beaker, one digital scale, one glass test tube, paraffin, one pipette, one stirring rod, labeling tape, hydroxide water wash bottle, acetone, test tube rack, and drying oven. Procedure: Day 1. Label the test tube with the period and table number. Label the 250 milliliter beaker with period and table number. Find the mass of the copper wire, 50 milliliter beaker, and the combined mass. Coil the copper wire with a pen or pencil and stretch it slightly. Place the wire into the test tube and pour 15 milliliter of the silver nitrate. Make sure the wire is completely submerged. Record the reactions that occur in the next 30 minutes. Day 2. Clean your silver crystals. Day 2. Clean the silver crystals off the copper wire. Dip the clean wire into acetone and wait for it to dry. After the wire is dry, find the mass and record. Decant the silver crystals back into the first beaker with the pipette. Rinse and stir the silver. Repeat up to 3 times until there is only silver left. Dump the waste into the 600 milliliter beaker. Give the silver and beaker to this man to dry in the drying oven. When the silver is dry, measure the mass and record.
Raw data of the investigation included mass of copper wire before the reaction, mass of empty labeled beaker, mass of the copper wire after the reaction, mass of the beaker with dry silver crystals, and the mass of silver crystals. The expected ratio of moles of silver to moles of copper was 2 to 1, which proved that the presence of copper 2 ions were there rather than the copper 1 ions. The percent yield of silver was 76.61%, and the percent error of the silver was 23.39%.
Our investigation with copper and silver nitrate was performed in order to deduce what kind of copper ions were produced by the end of the reaction. A copper wire was left in a test tube for 24 hours, and the qualitative and quantitative observations of the experiment were observed. The original hypothesis was that copper 2 plus ions were produced, and this was proven to be accurate, versus copper 1 plus ions. And this relates to both real life in that these compounds are used in both biology and medicine. As we can see in our balance equation, Cu plus 2Ag NO3 yields 2Ag plus Cu NO3 2. It was deduced that oxidation, which is the loss of electrons, reduction, which is the gain of electrons, and spectator ion, which is an ion that doesn't affect the amount of electrons in other ions, all existed. element that was oxidized was copper, and the reduction occurred to silver, which both lost and gained 2 electrons respectively. And the spectator ion in this reaction was the nitrate. The 1.08 gram copper wire was left in the silver nitrate, and by the end of the reaction, we were able to calculate that 0.05 grams of it was reacted. And after the copper wire, which had crystallized silver on it, was flushed with purified water, we learned that 0.13 grams of the silver was measured. And the ratio of the moles of the silver to the copper was measured to be about 1.5 to 1.
Looking at the balanced equation, we can see that for every molecule of copper, there should be 2 molecules of silver, setting the ratio of moles of silver to moles of copper at 2 to 1. This means that the copper ions produced should be 2 plus instead of 1 plus. We can see that 0.0008 moles of copper were reacted, and the expected outcome was 0.0016 moles of silver, and only 0.0012 moles of silver were formed, setting the percent yield to 76.61% and the percent error to 23.39%. Some of the sources of error in our experiment could have come from human error or experimental error. Some human error could be decanting too much silver, not decanting enough silver, not drying silver enough, too much solution in the beaker, not enough solution in beaker, not recording mass correctly, or not leaving the solution in the beaker for enough time. Some experimental error could be weak silver nitrate, unclean glassware, impure copper wire, faulty scale, weak acetone, or a faulting drying oven. This is our bibliography, and thank you for watching.